Okay, so our problem is 440. Let's read the question first. Um, the force F 600I plus 300J minus 600K in newtons acts at the end of the beam. Determine the moment of the force about point A. So we are asked for the moment of the force which acts at point B about point A. So what we need to do is we need to determine the relative position vector of point B with respect to point A. In order to do that, first we need to calculate the position vector of point A and then point B. Now the coordinate system is given. We have the x-axis, z-axis is vertical, and y-axis is along the beam. We have a u-beam here. The length of the beam is given, it is 1.2 meters. Height is given as 0.4 meters, and the width of the beam is given as 0.2 meters as well. Okay, so we will first write the position vectors of point A and point B, then we will subtract the position vector of A from B. This is what we are going to do. Now let's write the position vector of A first. In fact, RA is equal to 0.4 K vector. As you see, both point A and O is on the same axis. Therefore, it is just the height. Now RB is equal to 0.2 I vector plus 1.2 J vector plus 0.4 K vector. Of course, here you see the x-axis is 0.2 meters and the y-axis is 1.2 meters, and the z-axis the point B has a distance from the origin 0.4 meters. Okay, now we write the RB. Certainly we need to calculate the relative position of B from A. B with respect to A, I apologize. In fact, we have only Z components which are common. So minus RA means that gives us minus 0.4, and this term will cancel this term, and as a result, relative position vector of B with respect to A, which we denote by R, as 0.2 I plus 1.2 J. Now, in order to calculate the moment of this force with respect to point A, we will multiply R vector with F with a vector product. So R vector product F. Now let's write the vectors. So this is our position vector. It is 0.2 I plus 1.2 J. Vector product 600 I plus 300 J and minus 600 K. Now let's do the multiplication of each component. So first we multiply I with I. Okay, 0.2 I multiplied by 600 I. So if you multiply 0.2 with 600, you are going to find 120. But I vector product I will give us 0 because they coincide. So both vectors are on the same in the same direction. That's okay. Now next we will multiply this component, I component, with the J component. So this term with this term. If you multiply I with J, so you put your elbow on the x-axis and curl your fingers towards the y-axis. As a result, your thumb will show you the z-axis. And in fact, it is K vector 0.2 multiplied by 300 will give you 60. so it is 60 k vector. Now if you multiply this term with this one, so I multiplied with k. Now just put your elbow on the x-axis again and curl your fingers towards the z-axis. As a result, your thumb will show you negative y direction, right? But here we have another negative sign here, and as a result 2 negative will make positive, and in fact we have plus 120 j vector. Okay, so this is about the first term. Now let's look at the second term. We multiply this term with this one. This is our first vector product. So 1.2 j vector multiplied with the I vector. So from j to I it is negative z direction. As you see, my thumb will show you the negative z direction. In fact, 1.2 multiplied by 600 will give you minus 720 k vector. K is the unit vector in z direction. Now next thing is we will multiply j with j. Again, both vectors are in the same direction. As a result, vector product will give you 0. And the last multiplication is multiplying 1.2 with 600k. So 1.2j multiplied by minus 600k. Of course, this is makes minus 720. But if you multiply j with k vector, so again, if you put your elbow on the y-axis and curl your fingers towards the z-axis, your thumb will show you the positive x-axis. In fact, positive and minus negative sign will give you a negative value. It has minus 720 I vector. If you do the operations, what you are going to get is at the end, so the straightforward operation, the moment vector will be minus 720 I vector plus 120 j vector negative 660 k vector, and the unit is in Newton meters. Okay,